G'day, welcome back. Last lesson we looked at the sine function and how we could sketch the basic sine function, which we have on the board here, of y is equal to sine x. What we looked at last lesson, we'll do a quick recall, is that we record that y equals sine x has an amplitude of 1 and it has a period of 2 pi. What we're going to be doing today is we're going to be changing the amplitude. But what I want to do here is, whenever we talk about changing the amplitude, we actually talk about dilating the amplitude. So when we're talking about dilating the amplitude, we're talking about just how we're expanding or contracting the graph. So in terms of the dilation of the amplitude, all we're doing here is changing one variable in our equation. So we can rewrite this equation y equals sine x as y is equal to a sine x, where a, if you recall from that last lesson, affects the amplitude. So at this point right now, the amplitude of y equals sine x is 1. So therefore that's why it's just y equals sine x. If, however, we got a graph and we wrote y is equal to 2 sine x, then we're changing how high the maximum and minimum of this graph is going to be. And what it doesn't do is it doesn't change your period and it doesn't change your x-intercepts. They stay the same. So we can safely say here that we can put these points here as staying exactly the same. All that's changing is the height. So we're just basically dilating it, moving it, expanding it out. So in this case here, we'd start at 2 and go down to -2. So we'd put our dot up here and we'd put our second dot down here. So we start from 0 again, we come up to 2, where the amplitude comes, down through pi, shares the same x-intercept, down to -2, and then back up. So as you can see when we look at this graph here, that the change of the a value just changes the height of your maximum and minimum points. So we can write over here what it does. So it changes the max and min turning points. What it does not do is it does not affect the x-intercepts. And it does not, and we'll write this here, does not affect the period. So basically when it comes to changing your amplitude, we are basically changing the height. So if we took a third example here and wrote y is equal to 0.5, or let's write this here, half sine x, then I'm then coming down to here and saying, well, here is half, here is half. And again, I'm just putting my points where the turning point would lie. And you can see that it's exactly the same period, exactly the same x-intercepts, I'm just changing the maximum and minimum turning points. And if I was going to make this here a negative, so we recall from the last one it was a negative, then I just basically reverse the graph. So let's quickly go over what we looked at. We looked at when we change the amplitude, we're actually dilating the amplitude. Try and think of your eyes. When you dilate, your eyes dilate, they get larger or they get smaller according to the light. So we're actually either expanding or contracting, dilating it. The A value controls that dilation And the A value is always positive. So therefore, amplitude always positive. So we quickly looked at that in the last video, that if it says negative half, I'm not just moving down to negative half and that's it. It means that this here's how far away from the principal axis you're going on either side. All right. See you next one.